Like he stopped engaging. He was just lying under the table, hiding. He didn't want any contact. And that's not him. Usually he follows me around wherever I go. Like he stopped engaging. He was just lying under the table, hiding. But yeah, now he's good. Now he's good. Good morning, Leah.
Hi.
Hello.
Hello. Right, there should be a few more people dropping in, so I'm just gonna wait.
Monday difficult, always.
I know, rainy Monday.
Difficult.
Actually, I had to go for a walk already. Oh, do you have? This is so not okay, Abby. What are you doing?
My office, I do what I want.
Kids do not play with fire for no good reason.
Yes.
I had to go for a walk already, and like I opened the door and both my dog and I were like, not sure about this. But it's actually, it looks and sounds worse than it is once you're out there.
Oh.
But it's cold.
Yeah, rainy and winter is coming.
Now I just got a picture from Germany and they have snow.
Ah, yes, yeah, that should
like proper stay on the ground snow. Beautiful.
Was in Italy, they said me yesterday.
Cool.
It's a pity we don't have snow in Bordeaux. Yeah,
Do we never get snow here?
Almost never, but
it's like 1 degree. This rain could also nicely turn into beautiful powder.
Yeah, I don't know if our roof can resist the snow. It's enough for the rain.
Yeah.
Good point.
Exactly.
Given that we all had a leak. Given that we all had a leak, you might be right here.
Yeah, also like it was like 2 days ago, it was raining so heavily. I said, oh my God, now.
Something about roofs in Bordeaux, they're just not made to last.
Imagine with the snow. Oh.
Hi, Antoine. Nice to see you.
Hello. Hello, Etienne.
Right. Now, let's make a start. It's 9:31. Today we have Lilith, who used to be a master's student, partially in Italy, partially with us here in Bordeaux, and she's going to present a paper today for us. As always, if you have questions, there will be a discussion afterwards, and for those following us over on YouTube, you can just write your questions in the chat and I will bring them over and ask our presenter. That's it from me. Lilith, take it away.
Okay.
Oh, can you also share the link to the paper, please, in the chat?
Yes, 1 second. Okay. Okay, link is in the chat.
Lovely, thank you.
And share screen. Okay. Can you see it, right? Okay. So, hello everyone. Again, I'm Lilith, and I'm glad to present you this paper that I don't know if it caught my attention, and it was published 1 month ago in Frontiers in Aging Neuroscience. So the title is From Neurodevelopmental to Neurodegenerative Disorders, the Vascular Continuum. I got curious about this paper because in my mind, neurodevelopmental and neurodegenerative disorders, they were separate. So like on one side, we have neurodevelopmental disorders. They have their own etiology, causes, problems. And on the other side, we have neurodegenerative disorders with other reasons and mechanisms. But however, this paper, it kind of changed my mindset about this because it seems there are so many common features between these neurological disorders that are occurring throughout life. So yeah, and this paper, I don't know, at least as the way I see it, I think it's like kind of a new framework or a new way of thinking about this diversity of neurological disorders that actually can be put on one continuum, the vascular continuum. So what is the main logic behind this way of thinking? So we know that our brain is very hungry organ, and it needs a lot of energy, and this energy we are getting from blood vessels that contain vital nutrients and oxygen. And if we have some type of problem in our brain vasculature, so with this kind of transport system, then our brain simply stops working properly. And it's like, I don't know, a situation when we want to bake a tasty normal cake, but we don't have a proper functioning oven. So it's the same way I see it here. If we have a problem with brain vasculature, then we will get some type of problems. And the authors of this paper are focusing on 3 key vascular features. And they're saying if we are getting some type of problem here, then this can contribute to both early and late onset neurological disorder. What are those? What are these vascular features? So the first, we need to have a functional blood-brain barrier. Then we need to have dense vasculature to have adequate perfusion of the brain. And also we need proper regulation of cerebral blood flow. This cerebral blood flow, and if we get the problem, then we are getting neurodegenerative disorder here, or neurodevelopmental. So the blood flow is orchestrated here with not only with neurons that produce some type of neurotransmitters and then they changes the size of vessels. No, there are actually also glial cells like astrocytes or microglia that also contributing in regulation of cerebral blood flow. And also even there are some cells that constitute blood vessels that also regulate changes, vasoconstriction and vasodilation of blood cells. So for example, I'm talking about in the internal layer that consists of endothelial cells. And then we have smooth muscle cells, that is the second kind of layer of the blood vessels, big blood vessels like for example, internal carotid artery or arterioles. But in capillaries, we don't have smooth muscle cells, we have just pericytes. So any problem connected with this part of the system that they call the neurovascular unit will contribute to both early and late onset neurodegenerative and neurological disorders. Yeah, so what is happening next is that they are reviewing from vascular impairment perspective neurodevelopmental disorders such as autism spectrum disorder and schizophrenia. And then they're mainly talking about neurodegenerative diseases like Huntington disease, Parkinson's, multiple sclerosis, and Alzheimer. The cool thing of this article that they also summarized everything in a table where we can see key features, key alternations in cerebral blood flow or some problems with the blood-brain barrier. So overall, this paper, I really like the structure of this paper because in the beginning of each section, they talk about general features about the disease, and then they provide different evidence connected with some vascular impairments, and also providing animal studies, examples from animal studies, and so on. So I don't know if for Neuroccino purposes it makes sense to go through each disease in detail. I will not do that, but I wanted to say some things in general. So first, I got an impression that endothelial cells are sort of a big deal in almost each disease. I don't know why it is the weakest point in the blood vessels, but it seems that it has some even in some cases causal relationship. For example, with autism spectrum disorder, they generated a mouse with some type of endothelial specific deficit, and it leads to the similar phenotype related to autism spectrum disorder. So it might be that the reason of autism spectrum disorder actually lies in endothelial cells. So, and also this endothelial cell problem appears in other parts, in other diseases as well. I don't know, it's an interesting fact that I would like to keep in my mind. And the second point that I found is that overall, I think they are talking about hypoperfusion. So in all these diseases, we have a decreased level of cerebral blood flow, although it's also not in all the diseases. For example, with schizophrenia, it depends on many factors, actually. It depends on if we have negative or positive symptoms. So sometimes we can see increased cerebral blood flow in some cases or at some stages of disease. So it's not always a decreased cerebral blood flow, but mainly it is that the problem is that. The third thing that I want to say is that it feels like this approach is still in the beginning, because there are some studies that they are providing. It feels sometimes there are contradicting results, or there are studies with small sample size and or with a heterogeneous samples, like that makes us really hard to compare results with each other. But I think this is an exciting approach that might allow to find the treatment, because if the problem comes from abnormal vasculature, then we need to kind of focus on how to sustain healthy vasculature rather than, I don't know, treating neuronal level, because like neuronal level might be just the consequences of the abnormal brain vasculature, might be. So, and then we have to kind of treat the reason, not the symptoms or consequences of diseases. And the last thing maybe I wanted to say about this paper is that I really like that they also focused on the facts that that people suffering from one disease, they can actually start suffering from another disease later in life. So for example, people with traumatic brain injury can develop dementia, or children with autism spectrum disorder can progress later in Parkinsonism, or people with schizophrenia might start having Alzheimer disease or Parkinson disease later in life. So this paper is totally ruined in my mind the walls between these diseases that I built up, and it feels like we don't need actually dichotomize or see these diseases like as separate disorders, and I feel like it's a nice way to look at it from totally different perspective that I've never thought before, and I thought it's interesting to share this new way of thinking. So yeah, this is overall what I wanted to say about it, and if you have any questions about maybe a specific disorder, I can talk about a bit, and I'm happy to have a discussion with you.
Lovely,
Yes.
thank you. Very interesting paper, Lilith. Are there questions? No, not yet.
Yes.
Oh, here we go. Go for it.
First, yeah, I'm first. Thank you, Lilith, for the presentation. Yeah, it's always interesting to see papers that merge or that go to a more continuum view of the diseases like schizophrenia and Alzheimer, Parkinson. My question is more that, so I went through a little bit the paper, I didn't read it, but I'm wondering if they talk about this CBF problem as a common factor, or is it specific, or is there any specific CBF problem to a certain kind of disease, or did they try to deconomize or to find what is specific to, for example, for Parkinson and schizophrenic patients based on the CBF patterns, something like that?
I think they are mainly talking about either decreased cerebral blood flow or increased cerebral blood flow, but they are also saying in which brain areas it is occurring. So maybe depending on the region we get, that's why we get different symptoms of the disease. But I think it is not that specific, so I don't know if we can say that if we have decreased cerebral blood flow, then this person has, I don't know, Parkinson's disease. But maybe if we look at the region exactly, then it might allow us to predict what kind of disease have this person. But with, for example, multiple sclerosis, with multiple sclerosis, sometimes they have decreased cerebral blood flow, sometimes they have hyperperfusion. And as I understand, it depends on whether it is the multiple sclerosis in the active phase, when the immune cells starts to attack oligodendrocytes, or when it is in more stable form. It seems like there are some type of dynamics happening, but I still cannot look at the whole picture and say if this is so specific, but there are some variations happening at different stages of disease. Also with schizophrenia, if we have positive symptoms, we have either hyperperfusion or hyperfusion, and on negative symptoms, we have the opposite situation. Yes, kind of like this, I think.
And as a following question, that I'm wondering if they want to make a point as if it is these CBF abnormalities are the cause or the consequence, if they want to. Do they want to make this point, or do they want to be specific about the origin of the disease and based on the CBF? I don't know if I'm clear, but
yes. Also, I wanted to know this. I mean, to make sure if I understood them correctly about this, but I think it's not. I think they are not saying that it is the only cause that can happen that will lead to neurological disorder. They are saying that it contributes, but I don't know what contributes exactly might mean. But yes, so, and also if we say that everything comes from vascular problems, then might be we need to call these disorders not neurological but vascular diseases, no? So I don't know. And also, for example, if I go back to this a weird metaphor with baking a cake, what if our oven is works properly, but the ingredients are toxic and the cake is still not tasty or good? So, for example, with Parkinson's disease, I mean, to Neuroccino back, I think we were talking about Parkinson, and someone asked about if there are longitudinal studies that show some connection between gut and development of Parkinson's disease. So I found a study when they took people in a prodromal stage, and they did a biopsy of intestine, and they found aggregation of alpha-synuclein there already. And prodromal stage is like 20 years prior to diagnosis of Parkinson's disease. And they concluded, it's a study to 2017, as I remember, and they concluded that it can be a biomarker that might be the progression starts not in substantia nigra directly, but it starts already coming from gut, like through vagus nerve or something like this. I don't know. So yeah, it might be not only the oven is the problem, but also the ingredients that we're using, and not only vascular. But I don't know, they are not talking about this side.
Okay. Lovely. There is 4 more questions. So Leah, next.
Okay, thanks Lily for presenting. Yes, I agree. Like as you were saying, that the causality is really difficult to assess in these cases. And for me, it was not surprising to hear about neurodegenerative diseases that are also seen as a continuous, because there are also some also brain features, if you look also to MRI, that are shared. And as they were saying, neurodegeneration, they have a basic root, and then they can have different declination, let's say. I was surprised about the autism in this spectrum with vascular disease, also because if we look to the brain imaging, I'm not familiar. I didn't work with autism, but to what I know, it's really different from. I know there are some parallelism maybe with Alzheimer, but to me it seems different from the neurodegenerative spectrum. So I was curious about this, and also to know if there are actually data that support this, because also if we have vascular injuries in the brain, we can see them. Actually, I think to multiple sclerosis that you have the venous sign with the lesion around the venous. So I was thinking if we have this also in autism, because I'm not familiar with.
Yeah, so with autism, they're talking about, for example, connected with the cerebral blood flow again. They used, for example, with the ASL method, they found that Yeah, so that there are actually some hyperperfusion in frontotemporal regions, and so there are some data saying that there are alternations in cerebral blood flow, and this is what concerns about children, human, and also there are animal studies, and they go more specific because they can even manipulate with it. And with the autism spectrum disorder, there is this study that shows that they have normal vascular smooth muscle cells, the layer that goes after endothelial cells, but they have problem with endothelial cells. And then they generated a specific mouse with this problem, and it leads to similar pattern to this autism spectrum disorder. So yeah, there are some evidence, and this is and they have common features with the other neurodegenerative disease. And the fact that autism spectrum disorders can develop later in life Parkinson disease suggests that there is something that common, something in common.
Okay, thank you.
Thank you for the question.
Related to where you ended up in your answering, how did they measure autism in mice is a question that is in the chat from Valentina.
Yeah, I also was, when I saw it, like, what does it mean? What does it mean, autism spectrum related phenotype? How can they say that mouse has a autism spectrum disorder? I'm not familiar with these animal studies, but I guess it's the closer as they can get to somehow do causal relationship studies. So there is specific mice, as I understand, in this field, and it is used as a prototype of autism spectrum disorder. Yeah, but I don't know exactly how do they say that this is the same as the human autism spectrum disorder. And this is always a problem with animal studies, I think, but I'm not.
For this part, I think for the genetic mice, so I don't know a lot about it, but some works I done before was related to that. They base their phenotype on the social interaction of the mice with male and female, and how they behave each other. So, and this is a
not
genetic.
Necessarily exactly the same, but it's a model of the behavioral differences.
Yes.
There is a question over on YouTube, which kind of relates to the question I think Evie asked it earlier, but let's see if we can disentangle it further. I think there's a problem that can be generalized to most of the disorders described. Are these vascular alterations found to cause the disease, i.e. they lead to neurodegeneration in Parkinson's disease, or are they consequences of regulation once the disease has been established following other mechanisms? For example, hyperactivation of the putamen reduces cerebral blood flow locally, and those kind of mechanisms. It's the chicken or the egg.
Yes, so I really wanted to ask directly authors, so it will be super clear for me about their point. But again, they are using such words like that it contributes to the disorder. So does it mean contribution as a causal relationship, or it's one of the factors that contribute? I don't know. So honestly, I'm not sure if they think that it is the only reason that can lead to neurodegenerative or neurodevelopmental disorder, but it is definitely something that we can observe, and it might be the cause, but I don't think that it's necessarily that. But
so in the paper, they don't specify if it is the cause or the effect necessarily. Say it's related.
So with endothelial cells, for example, and autism spectrum disorder, they tell us that that this can show us that there is causal relationship.
Mm-hmm.
With other disorders, it might be not always the case. As I remember, if I can find that part.
It's always the pressure of showing the PDF live. It's like, I read it somewhere, but where was it?
Exactly. Yeah, in some cases that they write that we need more studies to establish causal relationships.
Well, that might be a question we can ask the authors because they were keen to engage anyways. So we can just relay maybe the conversation.
I think it would be better if when they just say directly if they think it is.
Right.
I might didn't maybe I didn't see it that clearly if they think that it is a causal relationship, but I don't think that in some cases maybe we can say it might be the cause, but in the other case it's just initial results that we have, and there are many with the schizophrenia, there are so many studies with different sample sizes and different patients. For example, those who are going under medical treatment, they show different pattern. Those who has a treatment, they show another pattern, and it's hard to compare because they showed a lot of studies here, but maybe it's not enough to say that it is the reason. I mean, if we knew that, then it will be easy with the I mean, there wouldn't be any discussions anymore. But I think it's still controversial, but a nice approach and exciting one for me at least.
Leah had another comment.
No, it was not a question. It was just say that, yeah, but you just say that really that is really controversial, and I heard in some conferences that is still a debate going on. So it's the main question if it's causal or not, and there are also clinical trials also with genetic going on to see if it's really difficult to assess the causality, I think. But yeah, the authors for sure will let us know the evidence of this. Just this, the comment.
It's a general thing that you can see, especially in the psychiatric literature at the moment, that we move away from trying to move away to define diseases as a behavioral cluster of symptoms and try to find more anatomical markers of diseases, which might actually then down the line alterate the way we classify certain diseases. And I think this paper is kind of feeding into that narrative by defining the diseases as a spectrum based on the vasculature rather than dichotomizing based on behavioral presentations. I have a final question that I sneak in, given that I can't see any other questions. But we know that the brain is variable in its anatomy, in its function, but the vasculature is even more variable between people. So I was wondering if there was any discussion on the variability and how to relate that complexity to complexity in clinical presentations.
Yeah, I think they were not talking about variability that much. So the only thing that they were saying that I think they were talking mainly in general terms that on average. So they are talking that we need to have. I think they were mainly talking, on axis of normal or abnormal. So if we have normal cerebral blood flow or abnormal increase or decreased, or for example, if we have dense enough vasculature or not. So it's like one axis, And I don't think that they were talking on another axis about variability of these features across patients. So, but yeah, I think it's might be interesting. But I think it's in this approach, it might be the second stage. So first, we need to establish if it is abnormal or not, how it contributes, or is it causal or not, and then look at another axis if this can we study variability to do more precise predictions about patients' progression to diseases. So yes.
Absolutely. Well, thank you so much, Lilith. Wonderful paper, great presentation. That's all we have time for today, but next week we're going to have Hervé present to us. Yes, a paper called A Model of Tension-Induced Fiber Growth Predicts White Matter Organization During Brain Folding, and it was just published last week in Nature Communications. So very much looking forward to that. And with that, I wish you a wonderful and exciting week in science, and we'll see you next Monday morning. Have a good week. Bye.
See you.
All right.